Hi everybody, this is going to be a walk around of my homemade tractor. As maybe you can see in this angle, I built it with two symmetric frame elements, and then I pivoted it in the middle there. I also added a pivot along the frame axis, which you might be able to see the shaft there that it pivots on. So it pivots both steering and ground clearance for the tires. You can see I put steering stabilizers on each side there. The way the steering works is I actually got a steering box out of an Isuzu pickup here. Let's see if I can tune in on that. That's a manual steering box that's geared over to the steering wheel due to the direction of the steering, and then coming down here you can see I've got a Lovejoy coupling to the main shaft pivot on the frame. The engine is a model 4A084, a mil-spec engine off of a generator. You can see that I salvaged some of the generator components there. I built a flange with a external gear hydraulic motor bolted to or coupled to the end of the engine shaft. So this is a 4-cylinder air-cooled mil-spec engine designed by the Army Corps of Engineers, rated. The design rating was 20 horsepower. This is very popular with the airboat and homemade aircraft crowd because you can strip off the shrouding, and with a propeller on it you don't need the shrouds, and it's a fairly lightweight air-cooled engine, which is great for those types of applications. So coming around here you can see from the hydraulic motor we're coming up to this spool valve here, which is actually a motor control spool valve, and that's really what makes everything work, because I used exclusively fixed displacement hydraulics on this. So the spool valve allows me to control the motor speed and go forward and reverse. The way the drive line works is we've got two Subaru Outback rear differentials, and I think since I've removed the floorboard you can see where I've just coupled hydraulic motors to each of the differentials, and they're solid mounted to the frame, and that's the reason I need this longitudinal pivot in the frame. So we got the two hydraulic motors. They're fixed displacement. The pump is 2.6 cubic inches per revolution. Each one of these hydraulic motors is around 7.5 cubic inches, so that gives me, once I go through all the math, this thing will drive consistently around 12 miles an hour, which is good for a tractor. I went ahead with the drive line. I just cut the rear axles to fit a narrowed frame. Coming around here you can see that yellow thing is the gas tank. That's simply a jerry can. This big tank here, of course, is a hydraulic tank, and that's sized due to the overall volume of the pump. It puts out about 25 gallons a minute, so the rule of thumb for vehicles is you take the gallons per minute and buy a pump or buy a tank that big. You can see I actually put trailer receivers on each end. What I'm going to use this for, and I really just am finishing it up, what I'm going to use it for is primarily a yard mule around the yard. I've got a tow behind mower that I'll use for the back lot as well. And other than that, I haven't quite finished the starting system yet. You can see the two batteries in there. I put that in the upright with the steering. They fit pretty well. The motor has got some advantages and disadvantages. It's got a governor on it, which is great for a tractor. It's also got a 24-volt starter and alternator built in. So what I've got is, I guess the door closed, I've got two motorcycle 12-volt batteries wired in series, and that actually starts it really well. Other than that, I just wanted to go through this for those of you that are interested. I'm not necessarily recommending that you go with fixed displacement. Those of you that know hydraulics know that variable displacement will give you much better control of the motor, but this is a hobby, and I was trying to do it on a minimum cost, and I ended up being glad I did it that way, because my goal was also to learn a lot about hydraulics, which I learned some anyway. So that's it.